Okay, so this is technically the last lesson of the unit. We may not get through it all today, but it's all one lesson. Okay, we're going to talk about some stuff that should be pretty familiar to us from Algebra 1. Almost all of it will revolve around this slope-intercept form, which we looked at in Algebra 1. You may have learned also about point-slope form and standard form, right? Well, we don't really care about those two, but so you did learn standard form last year? So standard form would be, no, I don't think you did, okay. So we're not really concerned about point-slope form, but we will talk about slope-intercept, okay. So do we remember what these letters stand for in this equation? So specifically the M and the B. Right, so M is slope, and B was the y-intercept. Okay. We may or may not remember exactly what these mean. Okay. What does the slope mean to you? If you had to write a definition of it, what do you think it means? If you know, if you have an idea. Nope. Okay. So slope is a number that indicates the direction and steepness of a graph. Okay. So slope is a number. It indicates the direction and steepness of the graph. Sorry about the handwriting. What about the y-intercept? If you're graphing a line, yeah, you usually start with the y-intercept. But right, so the y-intercept is where a line crosses or touches the y-axis. Okay. Okay. So to get a better idea of what this means, I'm going to show you here. Okay. So I have here an equation y equals mx plus b. Okay. Now I can take this slope, this top slider here controls the slope. I can take it and change it. Oops. So as I change the slope, we can see that the line changes as well. So the steepness of the graph, when we say it indicates the steepness of the graph, as you can see as I change it, the steepness of the graph changes, okay? Also direction. So when we talk about direction on graphs, we read them from left to right, okay? So here, as I pass into the negative side, you'll see that the direction of the line also changes, right? So if I'm reading this from left to right, a negative slope gives me a line that trends downward, and a positive slope will give me a line that trends upward, okay? That's what we mean when we say direction. Now, y-intercept, as you can see, I can move this line up or down based on the y-intercept because I'm changing where it's going to cross that y-axis, okay? Okay. All right, now this is something we should remember as well from Algebra 1 graphing equations, all right? So we have an equation y equals 2 over 3x plus 4. Jaden already told us that the first thing we're going to do is start with our y-intercept. Okay, so I'm going to start at y equals 4 up here. Okay. Now, how many points do we need to make a line? How many do we need at the very least? 2. You only need 2 points to make a line, okay? So how can we find another point here? Go up 2 and over 3 because we probably learned last year this slope is rise over run. Okay. Our rise here is 2, so I'm going to go up 2. Over, we always go to the right when we run. So that's my second point. Now I can take a line, draw me a line through here. Use your ID for a straight edge. Please don't draw these circles that y'all call lines. Okay. Right, and we've graphed that line. Now, you've learned, like I said, you learned probably before to make 3 or 4 or however many points you can, but you don't really have to if you know how to make a straight line. If you don't, then yeah, go ahead and find you some more points. Okay. Any questions about graphing a line? Nope, no. Okay, I'm going to give you like 3 minutes to go through and graph these last lines, and then we'll come back together. So if we look at the next page, we're now writing equations for graphed lines. Okay, so we're doing basically the reverse of what we did before. Okay. Which we should also remember from Algebra 1. So what am I going to do here? Right. Which one am I going to find first? Y-intercept, and what is our y-intercept here? -3. Okay, if we say at 5, make sure we're looking at the y-axis and not the x-axis. Okay. Okay, so the next thing sounds like we're trying to do is find a point where it goes directly through the corner of that grid. Which you may not be able to see this on your paper, but if I zoom in here, it doesn't go through. It doesn't really go through here. Okay. I think so. Jaden thinks it goes through here. It really doesn't go through here either. But at 7 and 1, it actually, at 7 and 1, it actually does hit where we need it to hit. Okay. So we can use that point. Now, what is that? Why is that point important to us anyway? It's going to help us find what? Yeah, it's going to help us find the slope, which is rise over run. And Alexis said if we start here, we go up 4 and we go over 7. So our slope is 4 over 7. Which I guess I should write this. 7, yeah. Okay. And of course, up is in the positive direction, going to the right is in the positive direction, so our slope is positive. And if we want to write our equation here, we can write it as 4 over 7x minus 3. Yep. Okay. Okay, looks like we're good on that. So again, I give you just 2 minutes, write the next 2 equations. And then I think we'll finally move on to the geometry part of the lesson. Okay, so actually there's one more thing we have to think about from algebra before we can look at the new part of this, okay? Now, do you remember hearing the word reciprocal in algebra? Do you know what a reciprocal is? Upside down, okay, yeah. So when we take the reciprocal, okay. So for example, if I have A over B, the reciprocal of A over B is B over A, right? So I'm going to take that fraction and I'm going to flip it. So just for example, if I have 3 over 4, reciprocal of 3 over 4 is 4 over 3, right? Reciprocal of a whole number like 3, the reciprocal of 3 would be 1 over 3, right? because we have an understood denominator of 1 there. Okay, what about opposite? What does it mean for numbers to be opposites? Right, so we're going to change the sign for opposites. So A would change to negative A. Okay, so for example, if I had 3, that would become negative 3. If I had negative 6 over 5, this would become positive 6 over 5. Okay. Okay, now let's think about opposite reciprocals, which is what we are really concerned with. What is an opposite opposite reciprocal is when we flip the fraction and change the sign. Reciprocal. Okay, yeah, I spelled it right. Okay, so the opposite reciprocal of, for example, negative 2. Positive, positive 1 over 2. What is the reciprocal of 4 over 7? Opposite reciprocal, negative 7 over 4. Okay, y'all got that. The other classes struggle with that a little bit. I don't know why. Okay. So, in a minute, we'll see why we're concerned about this opposite reciprocal. Okay. Hold on, we're going to look at this. Okay, I'm going to make it to where the slopes only go from negative 10 to positive 10 in increments of 1 for both of these. Okay, and then you said 5 and 8, right? All right. If I set this to 5, set this one to 8, that doesn't really look parallel. 1 and 5, okay. I'm going to change this one to 1. Okay, they still cross. Yeah, we're trying to make them parallel. 5 and negative 5? Okay. No, they're still crossing. I heard negative 1 and 10. That didn't do it. Negative 10 and 10. That didn't do it either. I mean, they can still be parallel with different y-intercepts. No, the y-intercept here is positive 2, here is negative 2. 5 and 2.5. Okay. Well, I can't do 2.5 because I set it to be in increments of 1, so I can't do 2.5.
You gotta do 5 and 5.
Do 5 and 5? Let's try that. Okay. So those look parallel, right? So anytime the slopes are the same, we say they'll be parallel. Let's see that. Let's see if we can see that here. Okay. So I've set them to where the slopes, so I'll change the equation to where the slopes will always be the same. Let's see if that's true. So we see that anytime the slope is the same, these lines are parallel, right? Okay. Now let's think about perpendicular lines. What do we think we have to do with the slopes there? Yes, but what does that mean? So perpendicular lines have to cross. Not only do they have to cross at a 90-degree angle, right? But what does that mean numerically about the slopes? How are they related to each other? The y-intercept, it doesn't matter here. I can't hear you, but think about what we just talked about. We talked about it for a reason. Okay. So the slopes are going to have to be opposite reciprocals of each other, and I can show that as well. So if I make this slope the opposite reciprocal, right? So the opposite reciprocal of m is -1 over m, right? And you can see that these lines are perpendicular. And actually, as long as we have opposite reciprocals, these lines will always be perpendicular to each other. Okay? And now you see how, I know you see that the orange line disappears for a second. That's because m equals 0 and 1 over 0 is undefined. But otherwise, they're still perpendicular. Okay? All right, so if we go back to our notes. We found that parallel lines have the same slope. And perpendicular lines have slopes who are opposite, Yeah, perpendicular lines cross a 90-degree angle, but we're talking about their slopes right now. Their slopes are opposite reciprocals. Okay. Okay. All right. Okay. Questions? Hopefully the visual was helpful, and hopefully it'll help you remember. So if we look at numbers 8 through 13, all we're doing here is simply looking at the equation of two lines, and we want to determine whether they are parallel, perpendicular, or neither. Okay. So if we look here at number 8, we have y equals 3x plus 4, and y equals -1 over 3x minus 24. Are these lines parallel, perpendicular, or neither? Perpendicular. And we know that because if we look at these two slopes, we look at these slopes, right? Find our slopes and we see the opposite reciprocals, so they must be perpendicular. Okay, what about number 9 here? Perpendicular as well, using the same kind of logic. Okay. All right, if we look at number 10. Parallel. Yep. 11. Okay, I heard a perpendicular, so they're reciprocals, but they're not the opposite of each other, right? The signs are the same, so we know they can't be perpendicular. The slopes are not the same, so we know they can't be parallel. They must be neither. You'll also see on assignments that I give you, maybe even on your test, I don't know, they may call these intersecting lines, which is true because they're not parallel. So these are intersecting lines as well. Okay. What about number 12? Neither, right? Or intersecting lines. And 13, parallel. Okay. Any questions about how we classified those lines? All right. How much time we got? 20 minutes. Okay. So knowing what we know about the slopes, we can write equations of parallel and perpendicular lines. So if we're looking at number 14, we want to write the equation of a line that is parallel to y equals 4x plus 8 and has a y-intercept of 3. Okay. Now, right. Okay. So if it's going to be parallel to this line, we know our slope has to still be 4. It told us that our y-intercept is 3. So this is y equals 4x plus 3. We can use the same logic on the next one. We'll find the line that's parallel and has a y-intercept of -23. So we know our slope must remain the same, which is -4 over 3. Our y-intercept is -23 because they told us that in the problem. Y equals -4 over 3 minus 23. Okay. Now the next one should be kind of familiar as well. I think we've done this procedure. The steps that we're going to use, we've done it before. Maybe just not with parallel and perpendicular lines. Okay, so we're going to write the equation of a line that is parallel to y equals 7x plus 15 and goes through the point 81. So firstly, if we know that it is parallel to this line, where's our slope going to be? So our slope is 7. Okay. Now, do we know what our y-intercept is? Nope, not yet. But we know that the line should pass through this point. Okay. Now, if we know y equals mx plus b, how can we use what we know to find our y-intercept? Yeah. Right. This is an ordered pair. We know ordered pairs always give us x and y values, right? So if we plug in our y, which is 1, equals m, which is 7, times x, which is 8, plus b. Okay. Then we're going to solve for b. 7 times 8 is 56. Right, yeah. So now we have 1 equals 56 plus b. Again, I'm just solving for b. Negative 55 equals b. Okay. So now I have my m, which is my slope. I have my b, which is my y-intercept. I'm ready to write my equation. Y equals 7x minus 55. Okay. Questions? Was that too fast? Good. Okay. Go ahead and work on the next problem. And then we'll come back for. Okay, so we should all have something. Well, not something like this, but we should all have this. Okay. Y equals 15x minus 55. Right. So with perpendicular lines, when we're writing the equations, we're going to do the same thing, except first we have to find the opposite reciprocal of the slope. Okay. So if we're looking at number 18 here, y equals 4x plus 8. And we want to make a line perpendicular to that one. What is our slope going to be here? Negative 1 over 4. Right? Okay. Then they tell us that our y-intercept is 9. So we're basically doing the exact same thing. 1 over 4x plus 9. Okay. All right, on number 19, once again, we're writing a line that is perpendicular to y equals negative 3 over 7x plus 4. Okay, so firstly, what is our slope going to be? Yeah, it's right, positive 7 over 3. Then we're going to follow the same steps we did before. So y is 3. Y equals mx plus b. So I have 3 equals 7 over 3 times 9 plus b. 7 over 3 is, 7 over 3 times 9, is 21. Yeah. So 3 equals 21 plus b. And I subtract 21 from both sides. Negative 18 is b. So now I can write my equation, y equals 7 over 3x minus 18. Okay. Okay. So I'm going to leave number 20 to you. I'm going to come around with an assignment for today that you can work on. I'm debating about when to have the exam in this class.